So, welcome to today's deep dive. We are jumping right into a really fascinating text today about the science and the psychology of background noise.
Yeah, it's a really compelling look at how we manage distraction, honestly.
Exactly. And uh, I mean, to start off, just think about this for a second. Have you ever noticed that you can sit in a super bustling coffee shop
Mm.
where the espresso machine is literally hissing, people are talking over each other, the door is swinging open and shut, and somehow, in all that chaos, you just power through a massive project?
Right, you just drop into this perfect flow state.
Yes. You are entirely dialed in. The words just pour out of you. But then the second you sit down in a perfectly quiet room like maybe your home office at midnight, where you supposedly have zero distractions,
You suddenly can't focus at all.
nothing. You
Yeah.
just stare at the blank page. Like every tiny sound in the house makes you jump. It's like your brain is just spinning its wheels in deep mud.
It's incredibly frustrating.
It really is. So our mission today is to unpack the biological mystery of why that happens. Because if you've ever experienced that contradiction, you are definitely not alone. It completely upends this idea that we need silence to be productive.
It really does. I mean, it forces a complete reevaluation of how human attention actually operates, like on a neurological level,
Right.
because we've culturally inherited this, I guess you could call it a monastic idea of focus, right? The solitary scholar in the completely silent
Oh,
room.
totally. Like the librarian constantly shushing you.
Exactly. But when you look at the mechanics of the human brain, specifically how we process sensory stimulation, silence is often the absolute worst environment for cognitive output.
Wow.
The worst.
Yeah, because our auditory processing systems they weren't evolved to function in a vacuum.
Okay, so if we look at an understimulated brain, what is actually happening in there? Because, I mean, I've noticed that when I try to work in a totally silent house, I don't just get distracted. I feel almost vulnerable, like the silence itself is aggressive. That is such a perfect word for it. And that feeling of vulnerability, it's actually your evolutionary hardware functioning exactly as it was designed to.
Wait, really?
Yeah. To understand why silence feels aggressive, you kind of have to look at the brain's sensory systems through the lens of threat detection.
Okay.
The human brain is basically a survival engine. It's constantly monitoring the environment, taking in acoustic data to establish a baseline of normalcy.
So establishing what's safe.
Right. In an environment with normal ambient sound, your brain's sensitivity, like what an audio engineer might call the gain on a microphone, is calibrated to a comfortable level.
The baseline is set, so the brain just knows what to safely ignore.
Exactly. But when you enter absolute silence, that external acoustic input just drops to zero. And the brain doesn't interpret that as, a peaceful opportunity to write a marketing report.
Right, it's not thinking about spreadsheets.
Not at all. In evolutionary terms, dead silence in nature usually means something catastrophic is about to happen.
Oh, like a predator is nearby.
Exactly. The birds stop singing, the insects go quiet. So because your brain is suddenly starved of its normal data stream, it actively compensates. It cranks that auditory gain up to maximum.
Oh, wow. So it's essentially turning up its own internal amplifiers because the signal dropped.
Precisely. It is straining to detect any possible acoustic anomaly.
Which explains so much.
Yeah.
That's why tiny sounds become disproportionately loud. Like the hum of my refrigerator, which I would literally never notice, suddenly sounds like a massive industrial generator.
Right, or a ticking clock becomes maddening.
Yes. You can hear your own heartbeat or just that high-pitched baseline whine of your own nervous system.
Yeah, you're experiencing auditory hypersensitivity driven by sensory deprivation. The brain absolutely abhors a sensory vacuum.
It's kind of like the visual equivalent would be sitting in a pitch black room.
Okay, yeah.
Like if the lights are on and a tiny speck of dust floats by, it's invisible. Your visual cortex ignores it because there's so much other data.
Yeah.
The furniture, the walls, the light.
The signal-to-noise ratio is balanced.
Right. But in a pitch black room, if you turn on a laser pointer, that one speck of dust floating through the beam becomes this massive, blindingly bright event. It dominates everything.
That is a fantastic analogy.
So in a silent room, a floorboard creaking 2 rooms over is that speck of dust. It completely derails you. But is this why it feels so agonizingly difficult to just start a task in a quiet library? Are we literally fighting our own heightened awareness?
We absolutely are, and the neurological consequences of that silence go way beyond just hearing the fridge hum.
What else is happening?
Well, when the external environment doesn't provide stimulation, The task-positive networks of your brain, the parts responsible for focused, goal-directed work, they start to lose their grip on your cognition.
Okay, so they sort of power down.
Because there's no external data to anchor your sensory processing, this other system, called the default mode network, or DMN, begins to activate.
Oh, the default mode network. That's the system that takes over when we're daydreaming, right?
Yeah.
The source of our internal monologue.
You got it. It is highly active during self-referential thought, ruminating, worrying about the past, projecting anxiety into the future.
Oh, so all the fun stuff.
Right. So you're sitting in a silent library trying to draft an email, and the lack of sensory data leaves some of your cognitive resources idle. Those idle resources immediately default to the DMN.
And suddenly I'm not thinking about the email at all.
No, you're thinking about a socially awkward conversation you had 3 years ago, or spiraling into imposter syndrome.
Oh my gosh, yes. The silence creates a vacuum, and my own unregulated internal narrative just rushes in to fill it.
Exactly.
So I'm burning so much energy just trying to suppress my own anxieties, rather than actually applying that energy to the work.
You are fighting a war on two fronts, essentially. The hypersensitivity to external sounds and the overwhelming volume of your internal default mode network.
That sounds exhausting.
It is. And this is why the source text points to the absolute necessity of a stable sensory layer in your environment.
A stable sensory layer. Let's look at the mechanics of that. Because the concept of an acoustic blanket makes intuitive sense. But how is that physically preventing my brain from panicking when someone, say, drops a mug in a cafe?
Well, it comes back to the acoustic startle reflex, which is managed by the brainstem and the amygdala. The startle reflex isn't triggered just by how loud a sound is.
It's not.
No, it's triggered by the suddenness of the peak, the delta between the background noise floor and the loud event itself.
Oh, so it's the rate of change.
Precisely. If you map it out, imagine a graph where the bottom is dead silence. A slamming door is this massive vertical spike jumping from near 0 decibels all the way up to 80 decibels in milliseconds.
Which is a huge jump.
A huge jump. That extreme contrast signals an immediate threat. Your sympathetic nervous system triggers a startle response, you get a hit of adrenaline, and your focus is entirely shattered.
And it takes so much energy to recover from that and get back into the zone.
It really does. But if you introduce a stable sensory layer, say the continuous hum of a coffee shop that's already operating at 60 decibels, you've artificially raised the floor of that graph.
Oh, so you've compressed the dynamic range of the room.
Exactly. Now, when that same door slams and hits 80 decibels, the jump is only 20 decibels instead of 80.
Right, so the relative spike is tiny.
Right, and your brain doesn't register it as a startling anomaly. The continuous wave of ambient noise physically masks the intrusion. You never get startled.
Which makes me think of the modern open plan office. Talk about a failure in this exact context.
Oh, absolutely. The open plan office is a nightmare for this.
Right. Because companies ripped out all the cubicles, built these huge cavernous rooms with hard floors, and didn't put in acoustic masking. So it's generally quiet, but punctuated by completely unpredictable transient sounds.
Yes.
A sudden burst of laughter, a stapler hitting a desk, a phone vibrating on glass. It's literally an environment engineered to constantly trigger everyone's startle reflex.
It is the perfect case study in acoustic hostility. Without that stable sensory layer to absorb the spikes, employees are just existing in a state of chronic low-grade hypervigilance.
Which has to elevate cortisol levels, right?
Oh, definitely. It chronically elevates cortisol and completely precludes any possibility of entering a deep flow state.
So if you're listening right now and you work in an open office, that is why you feel so drained. Okay, so the acoustic blanket protects us from external shocks. But how does it interact with the internal stuff? You mentioned it dampens the default mode network.
Right. It does this by acting as a gentle, continuous cognitive load.
Meaning the noise actually consumes bandwidth.
Yes. Your brain has a finite processing capacity. In silence, your excess capacity defaults to that self-referential rumination we talked about.
Right, the worrying.
But when you introduce continuous, moderate background noise, a small fraction of your auditory processing system is constantly engaged in monitoring that soundscape. It's a very low-effort task.
Yeah.
The brain easily categorizes rain or cafe hum as non-threatening, but it still requires metabolic energy to process.
Oh, I see. So I am essentially taxing the system just enough to prevent it from wandering off.
That's a great way to put it.
If my auditory cortex is busy processing the sound of the rain, The brain just literally doesn't have the spare computational power to spiral into existential dread about my to-do list.
Exactly. You are tethering the peripheral processing power of your mind to the present moment. That sensory layer consumes the exact margin of cognitive surplus that the default mode network would otherwise use against you.
That makes perfect sense for like data entry or procedural tasks where I just need to lock in. But the source text points to something much deeper, doesn't it? It says moderate noise actively changes how we think.
It does. It represents a major shift from seeing noise as just a protective barrier to understanding it as a cognitive enhancer. It encourages abstract thinking and creativity.
Which seems so counterintuitive.
It does, until you look at the balance between cognitive arousal and performance. This is often modeled by the Yerkes-Dodson law.
Okay, the Yerkes-Dodson law, that's the bell curve relationship, right? Where performance increases with mental arousal up to a point. But if arousal gets too high, performance just plumps.
Exactly. There is an optimal level of arousal for any task. Complete silence results in underarousal. The brain gets sluggish, dopamine drops, and we get bored.
And boredom leads to distraction.
Right. But conversely, severe overstimulation, like trying to write code at a heavy metal concert, pushes us past the peak of the curve into cognitive overload.
The prefrontal cortex just shuts down to deal with the sensory assault.
Exactly. So the goal is to surf the very top of that bell curve, the cognitive sweet spot.
And moderate noise puts us right there.
It provides just enough stimulation to maintain alertness without triggering a threat response. But to really understand the abstract thinking part, we have to talk about processing fluency, or rather deliberate cognitive disfluency.
Wait, disfluency? But I would assume we want cognitive tasks to be as fluent and frictionless as possible. Why would introducing friction help me think creatively?
Because when cognitive processing is too fluent, the brain takes the path of least resistance. It relies on its most well-worn, obvious neural pathways.
So the thinking becomes kind of superficial or algorithmic.
Exactly. But abstract thinking, or brainstorming, requires the brain to forge novel connections between disparate concepts. By introducing a mild level of ambient noise, you introduce a tiny amount of perceptual friction.
The noise disrupts the easy pathways.
It forces the brain to work just a fraction harder to maintain the train of thought. And this subtle increase in cognitive load pushes the brain out of its rigid linear mode and into a broader, more diffuse state of associative thinking.
Okay, I think of it like driving.
Oh, I'll hear it.
So if you're driving on a perfectly straight, flat, silent highway out in the desert, your brain requires almost zero arousal to manage the task. The processing fluency is way too high.
Right, you get highway hypnosis.
Exactly. You zone out, your reaction time drops, and you definitely aren't having any creative epiphanies.
Complete cognitive disengagement.
Contrast that with driving in chaotic, gridlock city traffic. Horns blaring, pedestrians everywhere. The perceptual friction is massive.
You're at the far right of the Yerkes-Dodson curve there.
Right, you're maxed out. You can't engage in abstract thought because 100% of your executive function is dedicated to just not crashing the car.
Right, fleet management.
But then, consider driving on a gently winding, scenic coastal road. The curves require active attention. You hear the wind, the ocean. There's a continuous stream of varied data.
You have to actively drive, but it's not threatening.
Exactly. The friction is perfectly calibrated.
Refuel.
Alert, your mind is sharp, and that is always the exact environment where you have the deepest conversations or suddenly solve a problem you've been stuck on.
That is a perfect analogy. The winding road creates optimal disfluency. It elevates your arousal just enough to engage those broader spatial and associative networks. Moderate ambient noise does that exact same thing for your workspace.
It's so fascinating that just the physical properties of sound can predictably alter our neurochemistry like that. But, the source text also brings up a completely different dimension to the coffee shop phenomenon, one that has nothing to do with acoustics.
Yes, the emotional atmosphere of the space.
Right. We are reacting to the sociology of it.
We're moving from the physics of sound to evolutionary psychology here. The research highlights the powerful effect of feeling socially connected without requiring direct interaction.
The text called it feeling alone together, right?
Yes. And to understand why this boosts motivation, we have to look at social baseline theory.
Social baseline theory. That's the idea that the human brain operates most efficiently when we are in the presence of a trusted social group, correct?
That's the one. For hundreds of thousands of years, isolation equaled death. If an early human was separated from the tribe, their nervous system had to take on 100% of the burden of threat detection.
Oh, so they had to be hyper-vigilant all the time just to survive. That is so metabolically expensive.
Incredibly expensive. But when surrounded by the tribe, the burden of vigilance is distributed, the nervous system downregulates, it feels safe.
The baseline assumption of the human brain is that we are safely embedded in a herd.
Exactly. So when we lock ourselves in a perfectly silent, isolated room to work, we are inadvertently stripping away the social cues that tell our primitive brain we are safe.
We are triggering that ancestral isolation panic.
At a subconscious level, yes. It triggers a low-grade stress response that drains cognitive resources.
But when you sit in a cafe, surrounded by the murmur of conversations, the clinking of glasses, you're getting a continuous stream of sensory data confirming you are safe in the herd.
Your parasympathetic nervous system engages. You feel secure.
But, and this feels like a critical distinction, the conversations have to remain distant, right?
Absolutely.
Because if the social presence demands actual interaction, the benefit just immediately collapses into distraction.
Oh, direct interaction carries a massive cognitive cost. If someone sits at your table and starts talking to you, demanding eye contact, parsing your facial expressions.
Formulating real-time responses.
Right. Your executive function is entirely hijacked by that social engagement. The genius of the cafe is that it provides the evolutionary comfort of the tribe with absolutely zero social obligation.
It's ambient humanity.
Ambient humanity, exactly.
It makes me think of body doubling. It's a technique used a lot in ADHD management.
Yeah.
Just having another human physically present in the room who is also working can dramatically boost your own executive function.
You tap into their momentum.
Yeah. In a coffee shop, you are essentially body doubling with 30 strangers at once.
Yeah.
You see others focused, and it creates this communal momentum.
It creates an atmosphere of normalized effort. The presence of others engaged in parallel play reduces the subjective friction of your own task.
It transforms work from this solitary, punishing exile into a shared experience. The environment is actively supporting you.
Right. You don't have to generate all the motivation internally.
So if the presence of ambient humanity and a stable sensory layer are the keys, it brings up a really crucial question about curation.
Curation of the soundscape, yes.
Because not all noise is created equal, right?
Yeah.
I can't just sit next to a jackhammer or turn on a random talk show and expect to drop into a flow state. The research has very rigid boundaries about what actually facilitates focus.
The distinction between ambient noise and intrusive noise is the dividing line between cognitive enhancement and cognitive sabotage.
Right.
We know chaotic environments with sudden loud sounds fail because of the startle reflex, but the most common error people make when curating their soundscape involves language.
Okay, yes. The text is unambiguous about this.
Yeah.
Lyrics-heavy music or intelligible conversations severely degrade concentration.
They absolutely do.
But I have to push back on this a little bit, or at least explore the nuance. Because this is where the theory kind of collides with popular habits.
Fair enough.
So many people rely on highly energetic pop music or hip-hop to get through their workday. Like if I am slogging through a tedious project, blasting a song with an incredible hook gives me a massive dopamine hit.
It elevates your mood.
It really does. It gives me the energy to keep going. Are we absolutely certain that this is sabotaging focus despite putting me in a great mood?
Well, we have to separate motivation from cognitive capacity.
Okay.
The dopamine release from hearing your favorite song absolutely increases your motivation and your task persistence. It makes you feel energized.
Right.
However, if the task you're performing involves language reading, writing, analyzing text, even internal verbal reasoning, the lyrics and the music are creating a severe structural bottleneck in your brain.
Because they're competing for the exact same neural real estate.
Exactly. When you process language, you are utilizing specific networks in the left hemisphere. Primarily Wernicke's area for comprehension and Broca's area for language production.
Okay.
You are also utilizing something called the phonological loop. That's the part of your working memory that temporarily holds and manipulates verbal information. And it has a strictly limited capacity.
So when I am trying to formulate a sentence for an essay, I am holding those words in my phonological loop before I type them out.
Yes. And when you simultaneously pipe intelligible lyrics into your ears, your auditory cortex routes that linguistic data directly into the exact same phonological loop.
Oh, wow. So they just crash into each other.
They do, because your brain cannot actively ignore intelligible language. It is an automatic, involuntary reflex evolved to prioritize human speech.
That's the cocktail party effect, right?
Yes.
Even in a noisy room, if someone says my name, my brain immediately locks onto it because it's constantly parsing the background noise for semantic meaning.
Precisely. By listening to lyrics while writing, you are forcing your language centers into a state of semantic interference. The brain cannot truly multitask.
It just microswitches.
Exactly. You're continuously micro-switching between the sentence you were trying to write and the sentence the vocalist is singing.
So the dopamine makes me feel like I'm working efficiently.
But your error rate increases, your reading comprehension plummets, and your abstract thinking is severely truncated because your working memory is constantly being overwritten.
I have experienced that literal overwrite. I'll be listening to a track, trying to type an email, and I will actually type the exact word the singer just belted out instead of the word I meant to use.
Yes, that is semantic interference manifesting physically.
The wires simply cross.
So the music has ceased to act as a stable sensory layer and has become a primary demanding input that actively competes with your work.
Okay, so that dictates the rules of curation. The ideal sounds must be predictable, gentle, and devoid of semantic content, like rain, soft instrumental music, or the indistinguishable murmur of a crowd.
Notice the common denominator there. Acoustic texture rather than acoustic information.
Texture, not data.
Exactly. Soft chatter in a cafe works specifically because the voices are blended into an unintelligible frequency band. You get the social comfort of the human vocal cadence without triggering Wernicke's area to parse the syntax.
That makes total sense. And this preference for predictable texture leads to a theory of attention in the text that I found to be the most profound paradigm shift in this entire discussion.
It fundamentally changes how we view distractibility.
It really does. The research suggests that background noise is effective not just because it masks other sounds, but because it gives the brain something small to ignore.
Right. This brings us to perceptual load theory, which was originally developed by cognitive psychologist Nili Lavie.
Okay, let's unpack this.
It resolves the apparent paradox of active filtering. To understand why giving the brain something to ignore increases focus, we have to look at the dual nature of our attentional system.
We have the top-down system and the bottom-up system, right?
Yes. Goal-directed, top-down attention is the executive function you are intentionally deploying to read a dense report. It is conscious and it is effortful.
And the bottom-up system?
Stimulus-driven, bottom-up attention is the automatic, subconscious system managed by older brain structures. It is constantly scanning the periphery for novel stimuli movement, flashes of light, or sudden sounds.
It's like the inner sentry. The distraction engine that evolved to make sure we noticed the tiger wrestling in the grass, even while we were intensely focused on foraging for berries.
That's a great way to think of it, and crucially, you cannot turn it off.
We're stuck with it.
We are. And more importantly, perceptual load theory states that perception is an automatic process with a mandatory capacity.
A mandatory capacity. What does that mean in practice?
It means if your primary task reading the report does not consume 100% of your perceptual capacity, the leftover capacity will automatically, involuntarily spill over to process whatever else is in the environment.
Oh, so if I am in a silent room reading a text that only takes up, say, 70% of my perceptual capacity,
that remaining 30% is highly volatile.
the inner sentry is fully armed, totally bored, and aggressively looking for a target.
Exactly. The sentry is actively searching for stimulation to consume that remaining capacity. Because the room is silent, the threshold for what constitutes an interesting stimulus drops dramatically.
So the sentry latches onto the sound of a distant lawnmower or the HVAC system and forces my top-down attention to process it.
And your focus is shattered.
But if I introduce a track of steady, continuous rain sounds?
You are artificially increasing the perceptual load of your environment. You are filling that remaining 30% of capacity with predictable texture.
The sentry locks onto the rain.
Yes, and because the sound is continuous and non-threatening, the brain quickly habituates to it, effectively deciding to ignore it.
But the act of ignoring is an active process.
That is the crucial insight. Ignoring a continuous stimulus is not a passive state. It requires a low-level continuous expenditure of neural resources. You are giving the distraction engine a full-time, low-intensity job.
The job of actively filtering out the rain.
Exactly.
I am giving the sentry a repetitive task just to keep it occupied. And because it's busy filtering the rain, it stops scanning the rest of the environment for anomalies. It stops pulling my top-down attention away.
You are saturating the periphery of your awareness so that the core of your attention remains stable.
That is incredible. I am fulfilling the mandatory capacity of my perceptual system without taxing my executive function.
Right, by intentionally providing an acoustic signal that is small to ignore.
This reframes the entire concept of concentration for me. We culturally assume that we have to focus despite the noise. Like ambient noise is this barrier we have to heroically overcome through sheer willpower.
Right, the discipline of silence.
But this theory proves the exact opposite. We are focusing because of the noise. We are actively utilizing acoustic texture as a tool to occupy the volatile components of our neurology. The noise is the scaffolding that holds our attention in place.
It really relieves you of the moral burden of focus. Distractibility in a silent room is not a failure of willpower.
It's a mechanical failure,
It is a predictable mechanical failure of an underloaded perceptual system.
which requires us to completely redefine what focus actually is. If it isn't the elimination of all stimuli, what is it?
Focus is a dynamic equilibrium. It is the precise calibration of internal arousal and external load. The historical pursuit of the perfectly silent study space, the heavy doors, the acoustic tiling, it was based on a fundamental misunderstanding of the brain.
Because too little stimulation leaves the perceptual system restless and triggers the internal monologue.
And too much stimulation, or the wrong kind of semantic stimulation, overwhelms the executive function and creates cognitive bottlenecks.
Somewhere in the middle, the equilibrium is achieved and concentration just flows naturally. We really have to stop fighting our environments and start engineering them. We need to act as the architects of our own cognitive states.
I couldn't agree more.
So if you are listening to this and going into your next work session, assess your acoustic environment critically. If you are sitting in silence, feeling your anxiety rise, your internal monologue racing, and your attention constantly snapping to minor sounds, do not try to force your way through it.
You are fighting millions of years of evolutionary programming.
Introduce a stable sensory layer. Put on a track of pink noise or rain, or the hum of a distant cafe. Give your perceptual sensory something small to ignore.
And conversely, if you are attempting deep, abstract work and finding yourself exhausted, evaluate your cognitive load. Are you sitting in an open-plan office absorbing a barrage of unpredictable transients?
Or listening to a podcast that is jamming your phonological loop.
You must ruthlessly curate the semantic input. Retreat to an environment, or simulate one with headphones, that provides texture rather than data.
It is about finding the specific frequency that matches the metabolic demands of your task. That magical flow state isn't a miracle. It's the result of aligning your physical environment with your neurological hardware. Let's review the architectural blueprints of attention we've uncovered today. We began by dismantling the myth of silence, right? Revealing how sensory deprivation forces the brain to maximize its auditory gain, turning minor sounds into startling intrusions while unleashing the disruptive power of the default mode network.
Then we examine the physics of the acoustic blanket, showing how a continuous baseline of moderate noise compresses the dynamic range of an environment, neutralizing sudden sounds before they can trigger the startle reflex.
We explore the Yerkes-Dodson curve and the power of processing disfluency, learning that a slight amount of perceptual friction actually pushes the brain out of algorithmic thinking and into the broad associative networks required for creativity.
We translated social baseline theory to the modern coffee shop, showing how the ambient murmur provides the evolutionary comfort of the tribe, creating communal momentum without the executive cost of direct interaction.
We established strict rules for soundscape curation, breaking down how the phonological loop operates and why piping lyrics into your ears creates devastating semantic interference.
And finally, we unpacked Nilly Labi's perceptual load theory, revealing the counterintuitive reality that active filtering is a metabolic process. By giving our bottom-up distraction engine a continuous texture to process, we saturate our excess capacity and lock our top-down attention onto the task.
It is a profound realization that our attention is a landscape we can actively manage. But as we close this deep dive, I know you wanted to pose a broader question for the listener about how we apply this in the modern world.
Yeah, I think it requires us to look at our current technological solutions through an evolutionary lens. We established that the human nervous system evolved in environments that were never completely silent. The baseline of safety for our ancestors was a world filled with continuous, gentle acoustic data.
The wind, water, the social group.
Right. Our neurology expects and requires that baseline to feel secure enough to engage in complex thought. So, if that biological reality remains hardwired into us, what are the long term psychological consequences of the modern obsession with high end, active, noise canceling headphones?
Oh, wow.
By utilizing technology to digitally erase the acoustic texture of our environment, are we actually optimizing our focus? Or are we artificially simulating the terrifying dead silence of a pre ambush environment?
That is wild to think about.
In our corporate pursuit of peak productivity, are we forcing our nervous systems into a chronic, unnatural state of hypervigilance that we simply do not have the evolutionary hardware to endure?
That is a brilliant and deeply unsettling question. Are we using incredible technology to build sensory prisons for ourselves, mistaking the panic of isolation for the discipline of focus? Definitely consider what signals you are sending your primitive brain the next time you flip that noise-canceling switch. Thank you for joining us on this exploration of the mind. We hope this knowledge empowers you to stop fighting your biology, engineer the acoustic scaffolding you need, and finally find your flow. We will catch you next time.